On to Mr. Mike Lusk from our Superior region to talk to us about the use of ultraviolet cured in place pipe liners. So take it away, Mike.
Thank you, Brad. You're a little too heavy on the Mr. there. That's my dad. So good morning, everyone. For those of you that don't know me, my name is Mike Lusk, as Brad said, and I am the construction engineer for the Newberry TSC. I'm here today to talk about ultraviolet cured in place pipe liners. We'll discuss a brief overview of the types of pipe rehab in general, some history of the UV liners and their use, process in which is made and installed, and a project overview, and some benefits to this somewhat new product being used in Michigan. There we go. So we have a few different forms of pipe rehab. And the first one I have on my list here is SIPP, or sprayed in place pipe lining or coating. It's a very simple process of applying material that could be a fiber reinforced polymer or a cement mortar and epoxy mixture to the inside of a hose pipe. It can be applied manually with a spray gun, or you can see in the one picture in the top left, that's actually a machine that's applies the material, and the material applied depends on the hose pipe and its intended use. The next one we have on here is slip lining. I'm sure we've all heard or witnessed an installation of slip line culvert or pipe, which is very simply inserting a smaller diameter pipe inside a larger pipe. And then what we do is we grout that annular space between the two to fill the voids. It's pretty straightforward. Next, we have our traditional cured in place pipe lining, where there is a felt liner installed, and then it's cured by either hot water or steam. This is the method I believe most of us are familiar with when we talk about lining culverts on our roads. And lastly, we have our new to us anyways method of lining, which involves the installation of UV cured pipe, which is what we'll be talking about here this morning. And all these methods have their benefits, and they, based on actual project needs. Oh, darn it. I'm sorry, I need to go back. I clicked too many slides. Maybe this would happen. Love technical difficulties. So, very brief history. I tried doing a little research on this. It came up mostly blank, but what I have found to be the technical term that started this whole thing out was ultraviolet light cured glass reinforced plastic pipe. And that's quite a mouthful. Or UVGRP, which is what the industry is utilizing. Seeing that our traditional method uses the CIPP, or cured in place pipe nomenclature, I've just been using them synonymously, and that may not be correct, but for the intent of this presentation, I'm using them interchangeably. So some background, very brief. In the late 80s, this process was developed in Scandinavia, and then it flourished throughout Europe before being brought to the United States in around 2005. And in Europe today, UV lining accounts for more than 70% of pipe rehabilitation projects. So the process, through the entire lining process, from manufacturing to installation, everything's done in a controlled environment. Raw resins arrive at the factory. They are tested against specs. Additives are mixed with the resin, and again, everything's tested against stringent specifications. Glass mat, it's fiberglass, is wound and wet out in an immersion bath with resin, and again tested. The liner is then assembled and loaded into shipping crates with barcoded tags, and they actually retain samples at the factory for verification and further testing purposes if necessary. So here in this slide, we have a picture of a fully QA QC checked liner that is ready to be shipped out to a contractor. Based on the diameter, the length of the liner produced, they vary greatly in size, and they can be extremely heavy, which this box here probably weighs, I'm guessing 10 to 20,000 pounds. A liner, a UV liner, can be stored for up to 6 months without refrigeration before it's installed. And the key here for this particular liner is that it's in a sun-proof box, keeping out any stray ultraviolet light. So as I mentioned, we did have a project, and in 2017, our office, or Newberry TSC, received the first glimpse into what a UV cured in place liner was all about. Our office designed and led a culvert liner project in the fall of 2016, with the actual starting the following summer. Upper Peninsula Rubber Company was a low bidder at around $415,000 on the project, which consisted of lining one very long, large elliptical pipe on M221 near Brimley, and then we had 11 median drain pipes on I-75 in Chippewa County. In the contract, in the proposal, we have special provision for cured in place liners, and that SP was originally written for traditional thermal cured liners. Again, cured either using steam or hot water, and it referenced those materials ASTMs. So the SP also required the contractor to provide a design in accordance with AASHTO HS20 load criteria, assuming a fully deteriorated pipe. UP Rubber Company proposed using a UV cured liner system from a company named Reline America, and their product was called the Alpha Liner. We actually had a very lengthy internal discussion about its permissive use, but eventually allowed them to use this product on the project. And that process in discussion back and forth, and I don't know if Mr. Dave Gothier is on today, but he was very involved in that, and it took approximately a month for them to be able to prove to us that it was equivalent or better than traditional cured in place. Also of interesting note, the liner thickness of this new material was less than 1/2 inch, whereas a traditional felt liner would have been slightly over 1 inch in thickness. So here we have the actual 57 by 38 inch liner being delivered to our M221 site near Brimley. And as I mentioned, they're heavy. This one weighed over 21,000 pounds. And also, as mentioned before, it's shipped in a UV or sunproof container to prevent any possible curing during transport. There's also an outer protective film on the liner itself. As I was told when on site, I guess if it had been indirect sunlight without a protective film on it, the liner material itself will actually start to harden and cure in approximately 10 minutes in the sun. So during installation, contractors personnel were very careful not put any rips or tears in that outer film. So to begin the installation process, a slip liner is installed into the hose pipe. And you can kind of see it in the picture on the left. It's kind of looking like it's almost like a white slip and slide. And that slip liner is there to aid in the UV liner placement process by reducing drag and preventing any tears in that outer film. Next, the liner itself is dragged or winched into place through the pipe. Smaller liners are easier to handle. They still require some wrestling. And that larger liner, weighing over 10 tons, was installed using a crane truck and special rollers to guide it into place and it was pulled through the pipe utilizing a heavy duty winch. So the next step is to install the UV light train inside the liner. You can see the picture of that on the right. For each individual application, based on the diameter and liner thickness, the lights put out a amount of wattage to initiate and cure the resin in the liner. It's basically a series, in this case, of 2000 watt UV lights that is pulled through. And I can remember when I was actually standing there watching this thing get set up, not realizing exactly what was going on. I actually got a sunburn from standing there for more than 5 minutes. So they are quite potent. So further on the installation process, so we have the UV light train is installed in the liner in the picture on the left, along with the camera, and the end is capped with what they call a packer or end seal, and you can see that on the right. The entire liner is then inflated with air to a very low pressure, and I remember it being like 4 or 5 psi, and doesn't go to a very high pressure. Once everything is in place, they pull the light train and the camera through the liner with the lights off to verify that everything is in place. And then, as we say, the magic happens. The lights are turned on, the light train is pulled through, and the resin in the liner is cured. And also, depending on the size and thickness, the speed of the light train is also varied. So here is another picture on the left of an end packer, or end seal or packer. This was on that larger elliptical 57 by 38 inch pipe. And underneath it, you can kind of see a white plastic lining. That's that slip liner. And on the right was the outfall of that pipe that was successfully lined. And some more before and after pictures. This was looking into the pipe. As you can see, it conformed to the shape of the deteriorated host pipe rather nicely. So it got a nice tight seal and followed the undulation of that deteriorated pipe. So some benefits. First and foremost, for me, the biggest one was that it's environmentally friendly. A UV light cured in place liner doesn't produce processed water contaminated with styrene like conventional liners cured using hot water or steam. This styrenated contaminated water is expensive to contain and dispose of, and if an accident does happen, mitigation would be abysmal. So with our large M221 culvert, we were very concerned about this possibility actually happening. The culvert that was lined was only a few hundred feet from a designated trout stream and approximately 2 miles from Lake Superior. And it would have actually been filled with around 33,000 gallons of this polluted water had we gone with the traditional method. Other benefits, it can be a realized lower cost due to not having to budget for the capture and treatment of that processed water. Based on the estimates at the time of this first project, the method was approximately 2/3 the cost of hot water cured. By cost comparison on smaller diameter liners, steam and hot water cured liners are currently running approximately 10 to 20% below the cost of UV cured. And it seems as though from 18 inches and up, approximately again, UV curing runs cheaper because of faster job setup and increased curing speeds, and not having to deal with all that processed water. In talking about strength, materials in a UV cured liner are touted to be more robust, and testing has shown that the long-term flexural modulus is up to 6 times stronger than the traditional liner material. The design life per the manufacturer for that felt liner is approximately 50 years and up to 80 years for UV cured. And to go along with that, the liner material itself is highly resistant to corrosive chemicals. So this will lead to lower life cycle costs within the increase in design life. Another benefit is thinner wall thicknesses. As I said before, in this example, we had less than 1/2 inch, whereas if we had utilized a traditional method, it would have been over 1 inch in thickness. So it maximizes the hydraulic capacity of the pipe. And I know in regards to QA/QC measures, everyone is very in tune with those procedures and the benefits they provide. So in looking at those, the liner is pulled into place, allowing full inspection prior to curing. The UV light train records all temperature data during the cure, ensuring a full cure throughout the length of the entire liner, instead of solely relying on temperatures taken at the exposed endpoints. And a video of the entire cure is recorded along with all of the data in an Excel file, which they provide to us. And last, I have on here for benefits, it will provide a viable pipe even when the hose pipe does become 100% deteriorated. I know in Chippewa County clay country, and I'm sure in other areas around the state that have acidic or caustic soils, that the design life might be only 30 years for a traditional metal pipe. And if we align them soon enough, we can get a new pipe inside them before we need to do some kind of more costly method of remove and replace. So just one last bit of information to go over. We do have an existing statewide contract, and it's with UP Rubber Company. They just so happen to be the same company that did this very first project, our pilot project, if you will. And that contract does cover Superior and North regions. To date in our area, approximately 23 culverts were lined, and we have 7 more yet to come. And then we have an ongoing construction project where we have 13 that have been UV lined again by UP Rubber, ranging from 15 to 18 inches. And that is what I had to share today. Does anybody have any questions?
Yeah, there's actually quite a few in the chat right now, Mike. In the spirit of time, I think I'm only just gonna pop a couple to you real quick. One being, can this be used with any pipe type? You know, concrete, CPM, CMP?
I don't see it being, you know, pigeonhole type of thing where it's a CPM or a CMP type. But if you had any kind of deteriorated pipe and it had roughly, you know, as long as it wasn't caved in, they still have to do culvert clean out, inspect, clean out, and then be able to pull that liner through. So in my opinion, it could be used on any pipe material. Okay, and then what about size? How big and how small? You know, I was looking at the actual on the low side, and I think they go down to like 4 or 6 inches. I know traditionally that, you know, the 15 to 24, 36 is the normal sizes, and I was doing some reading. I guess that we can do up to 72 inches. I guess they have done a couple in Europe. I think the largest one to date done in the United States was 60 inches. So when we get towards that, those larger size, the lights that they use, those UV lights used in the light train, are around 4,000 watts. And I guess there's a fine line between curing the product and actually burning it. So that's 72 inches is the theoretical limit at this point. All right, there are several more good questions here in the Q&A, and we'll get to those. Mike, we'll talk. I don't know if you can just enter in some responses, but we do need to roll on to our next presenter. So thanks much, Mike, for that. You bet.